Hello everyone. This is our second section of Unit 7 about data and statistics. Today we are learning about numerical measure, which includes things like mean, median, mode, standard deviation, the interquartile range, and outliers. We have this data here, 64, 71, 68, 73, 62, 65, 66, 67, 70, and 65. And that's the data set that we'll be using as a sample for calculating for each of our types of numerical measure. And then in our upcoming sections and in class a little bit, we'll be spending some more time calculating these things with some real life data, including some that we already took and recorded for the hand span versus height ratio and things like that. So today we're just starting with these numbers, and I know that some pieces of numerical measure for statistics require that our numbers are in order from least to greatest, and these are not. So the first thing I'm going to do is reorder these numbers into least to greatest. So I'm going to start with, I have 62, then I have 64, then I have 65, then another 65, then 66, then 67, I have a 68, 70, 71, and 73. All right, now our data is in order from least to greatest. All right, so now that we have done that, let's go ahead and take a look at our measures of, well, our numerical measures for statistical data. So we're starting with the mean. And the mean, by definition, or another way to call it, is the average. We calculate the mean using the sum of all values, so you're adding all our data points together, and you're dividing by the total number of data points, which in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 data points, and I'm actually thinking we should write that down. So we have, if you'll notice right here, I'll zoom in on this. This is what the official equation for the mean is. And you'll notice here we have the letter N, and that it represents the number of data points. That is true all the time for our statistical measure. So we are going to make a note up here that N is equal to 10, meaning there are 10 total data points. Other parts of our equation, we have X bar, or the mean, is equal to the sum of all data points divided by the number of data points. So what I had written to the side here, that sum of all values divided by the number of values, is just this written in a easier language. So I have X bar, or the mean. This is called capital sigma, and capital sigma is a letter, it's a Greek symbol that we use to represent the sum of. Then we have this X, which represents all data points, and we have N that represents the number of data points once again. All right, so we're going to go ahead and we're going to calculate this. So what we need to do is we need to take all these data points and add them together and put them on the top of our fraction. So I have 62 plus 64 plus 65 plus 65 plus 66 plus 67 plus 68 plus 70 plus 71 plus 73, and that's all divided by the total number of data points, which we found to be 10. I'm going to go ahead and simplify that fraction. I'm just going to write all that addition over, and I am going to use my calculator for this one to help us go a little quicker here. So 62 plus 64 plus 65 plus 65 plus 66 plus 67 plus 68 plus 70 plus 71 plus 73 is equal to 671 divided by 10, which means if we're dividing by 10, this is nice and easy. We just move our decimal point in one place. So the mean, represented by X bar, the mean is equal to 67.1. That's our mean. All right. So I think we've calculated the mean before. Now we're going to talk about standard deviation. And I know some of us have calculated standard deviation before. In Algebra 1 at WAMA, you calculate standard deviation by hand. We're going to change it up a little bit, and we're still going to calculate it, and you still can calculate by hand, but we're going to calculate using the calculator. The definition of standard deviation is the measure of the amount of variation of a set of values. So you are finding, on average, how far away each data point is from the average. That's what that means. We have two kinds of standard deviation. We have population and we have sample. This class is going to almost always be using sample. You're probably never going to use population in this class. When you get to Algebra 2 and if you take AP Stats, then you'll run into situations where you need to use both. But we're going to start with sample. So how to calculate? We again have capital sigma, which means the sum of. We have x bar to represent the mean. We have n to represent the number of data points. And we have xi, which means each data point. So in our equations, they look fairly similar. We're going to start with population here. And population says this is called rho. So rho is equal to the square root of the sum of all data points minus the mean squared divided by the total number of data points. This is population. That's what you use if the data set is the entire population. For this class, we're going to be using sample more often, which means SX, and this is what your calculator will show as your standard deviation, is equal to the square root of the sum of each data point minus the mean squared, all divided by n minus 1. And this is what you use if your data set is a sample from a larger population, which is, again, what you get most of the time. Typically, when you see statistics shown in like news articles, anything you might see from the school, other types of data, something you might see in a commercial, when you see those commercials for medicine and they say some people might experience all these symptoms, those are all statistics that come from a sample because they have not tested the entire population, because sometimes that's impossible to do because the population is too big. So we do our best to get an estimation based upon a small group of people, and that is what this equation is for. If we are calculating the standard deviation, we would use this formula. I could write this out so that you could see a little bit better. This is what you might remember from Algebra 1. Instead of having it like this, you would see under the square root, you'd have x1 minus the mean squared plus x2 minus the mean squared. And so on, it would continue, plus dot, dot, dot. And then you would divide this by, let's say that there were 2, then you would have 2 minus 1. If there were 5 data points, then you would have 5 minus 1, and so on. This is a simplified way of writing that long equation. And because our calculator can do this for us, that's what we're going to do. Because if you have, let's say you have 50 data points, calculating the standard deviation with 50 data points would take a really long time. So this is what you do with the calculator. And there will be a video of me showing you how to do all this in a minute. For now, we're just going to write down all the steps. So step 1, press the Stat button. Step 2, select Edit. 3, enter your data into List 1. It's called L1. Step 4, you're going to hit the Stat button again. Step 5, press the right arrow key to get to the Calc on the top menu. Step 6, select one var stats, that's one variable statistics. Step 7, the list should say L1. Step 8, arrow down to calculate and press enter. Step 9, SX is your answer. If you have a different kind of calculator, I used the Texas Instrument TI-84 Plus. This is the calculator that I used. If you have a different calculator, I am most likely not going to be able to help you on learning how to use these things, so I recommend Googling it, or if you know someone who does know how to use the calculator, that you ask them. If you have an older model of the TI or the Texas Instrument calculator, like the TI-83, I can help you with that. It's going to look a little bit different. You'll just need to ask me individually because most of us have the TI-84 Plus. All right, so that is standard deviation, and when you calculate standard deviation, I actually already pulled it up so that when you finish with that video, you should end up with a standard deviation of 3.41. So let's go ahead and write that down. For our data, that we have a standard deviation, X is equal to 3.41. And that is an approximation. So that's what you're looking for, 3.41.
All right, here we have our graphing calculator. The first thing you're going to do to calculate standard deviation on your calculator is to hit the stat button right here. Then you're going to use the arrows if you need to and go to option 1 and hit enter. If you have data in this column like I do, you're going to hit this up arrow, and now we have a highlighted L1, that's list 1, and you're going to hit the clear button. Then you're going to hit the down arrow and your list will be empty. Now you're going to go ahead and you're going to put your data in the calculator. So I have 62, 64, 65, 65, 66, 67, 68, 70, 71, and 73. Now that our data is in L1, we're going to go ahead and press Stat again. Now we're back at the same menu and we have Edit, Calc, and Tests at the top. We want to arrow over to where it says Calc, and this is where we can calculate a bunch of different things. For our statistics unit, most of the things that we are looking at will be in the very first option. That is the one var stats, one variable stats. You're going to select that option either by clicking the 1 or you'll hit enter on that list. You want L1 as your list because that's where we put our data. Then you're going to arrow down to calculate and hit enter. When it does that, it calculates several things for you. The first thing, just like we were talking about with the mean, we have x bar is equal to 67.1. That's our mean. Then right below that, it's the sum of all our data points. Then we have standard deviation right here, Sx is equal to 3.414023368. That is our standard deviation. That's what you're looking for. I'm also going to show you real quick. There's the row X. That's the population standard deviation. We're not really going to be using that, but that's where that is. There's 10 total data points, and then if you arrow down, it gives you your minimum value, your Q1, your median value, your Q3, and your maximum value as well. You'll notice that there is nothing about the mode or outliers on there. You have to calculate all of those things by yourself. Your calculator will not do that for you.
All right, now we're going to talk about the mode. The mode, and our abbreviation for mode is MO, is equal to the most frequently occurring number. So it's the number that comes most often. To find the mode, it's easier to find it if you list them in order from least to greatest. We already did that. To find it, you just find the one that occurs most often. There's two special cases. You could have no mode, which means that you have one of everything, or you could have more than one mode, which means that maybe you have two separate data points. So if we look at our data, we're going to go back up to the top here. We have 65 occurs twice, and nothing else occurs twice. Everything else only comes once. So our mode is going to be 65 because that's the number that occurs most often. Let's go down here, and this is our mode, and our mode MO is equal to 65 because it occurs most often. All right, let's go ahead and turn the page where we will talk about a couple more methods of numerical measures. So we have the median. The median, abbreviated MED, is equal to the middlemost number. So to calculate this, step one, reorder the data from least to greatest. We already did that, so that's done. 2, find the middle number. If there are 2 data points in the middle, you're going to need to add them together and divide by 2. You're finding the average of the 2 middle points. So let's go ahead and go back to that other page and look at our list here. We want the middle numbers. So I'm going to set my iPad down here a second, and we're going to point from each end and go in. So I have 73, 62, in, 64, 71, 65, 70, 65, 68, 66, 67. Oh, we have that problem. We're right in the middle. We have 2 data points. So we need to find the average of the point 67 and 66, which this one is pretty easy to calculate because it's halfway between those 2 things, so it's going to be 66.5. But just to show you what you would do in case you can't figure that part out, you have to add those 2 things together. So I'm going to pull my pencil back out here a second. So we had 66 plus 67, and we're going to divide those 2 things by 2. 66 plus 67 is equal to 133. That divided by 2 is equal to 66.5. So our median is equal to 66.5. All right, next we have our first quartile. And in order to understand our quartiles, you do have to have a pretty good understanding of the median, because the median is used to calculate both the first quartile and the third quartile. So our first quartile, Q1, is equal to the middle number, or it is the middle number between the smallest data point and the median. So essentially what that means is it is the middle of the bottom half of our data. In order to calculate it, you're going to reorder the data from least to greatest. Then you're going to find the median of the whole data set. Well, we already did those 2 things when we were working on the median, so we already know that. And 3, find the median of the lower half of the data set. So let's go ahead and go back to our data set, which was on the other page. And I'm going to label the median in this data set. So the median was right in between 66 and 67 at 66.5. That was our median. And when we are calculating Q1, and we're going to do the same thing for Q3 in just a minute, you don't include the median itself. So we're going to do that thing again where we start from the ends and work our way in to find the middle of the bottom half of our data. So I have 66 and 62, 65 and 64, and this right here must be our Q1 because it is the middle of the data below our median. So this is Q1, 65. So let's go ahead and circle that. 65, that is our Q1. And we will go ahead and write that on the other page as well, that we have Q1 is equal to 65. All right, next we have Q3. It works very similarly. In fact, the steps are exactly the same. It's just Q3 is the middle number between the median and the largest data point. And the steps say reorder from least to greatest, find the median. We did both of those things. Find the median of the upper half of the data set. So let's go ahead and go back to our data on the other page. And this time we are going to go in from the number to the right of our median, which is 67, and our largest value. So I have 67 and 73, 68 and 71, and then this is right in the middle of all that. That is our Q3. That is 70. So I'm going to go ahead and circle that. We have 70 is our Q3. So now let's go ahead and go back to our other page and write that down. So I have Q3 is equal to 70. All right. So now that we have found Q1 of 65 and Q3 of 70, we can use that to calculate another piece of numerical measure, which is called the interquartile range. The interquartile range is the difference between Q1 and Q3. In other words, Q3 minus Q1 is equal to our interquartile range. And you'll notice here that I have IQR. We always write interquartile range as IQR. You probably will never see it written out as a word in any formula. It'll always be written as IQR. So let's go ahead and solve that. We just said that our Q3 was 70, and I remember that our Q1 was 65. So to calculate our IQR, we are going to take our Q3 of 70 and we are going to subtract our Q1 of 65, which means that our IQR must be equal to 5 because 70 minus 65 is 5. That's our interquartile range. Now, the reason why we call it a range, as we go to our next numerical measure, that is the range. The range is the difference between the largest and smallest values of a data set. In other words, the range is the largest value minus the smallest value. So we're going to need to go back to our data set one more time, and we are going to find our largest value and our smallest value, and then we'll use that to calculate our total range. So as I'm going back to that first page, I'm noticing that my largest value is 73 and my smallest value is 62. So I'm going to go back and I'm going to remember that 73 and 62. I'm going to write that down real quick. My largest value was 73, smallest value was 62. Now we're going to take those two things and we're going to subtract them to find the overall range. So range is equal to 73 minus 62. So range is equal to 73 minus 62 is equal to 9. So our range is 9. Our numbers are within 9 points of each other or less. The range and the IQR are both helpful when you're trying to figure out if you have any outliers. And outliers are values that lie outside most of the other values in a data set. In other words, what we're really getting at is that sometimes you have one number that doesn't quite look like the rest. So let's say in our data points, which went from 62 to 73, let's say we also had the number 1. Well, that doesn't really fit in with whatever we're calculating because 1 is really far away from those things. When you're finding an outlier, sometimes you don't have to calculate anything because you can just tell. Like if we had 1, it'd be really far away. It's pretty obvious. But what if you're not sure? Well, we actually have a way to calculate that too. We have the lower boundary, which is equal to Q1 minus 1.5 times the IQR. And to find on the upper boundary, we have Q3 plus 1.5 times the IQR. So what's really happening here is this is giving you a little bit of a measure. It's boundaries for when you know with the upper boundary, that means that anything that is past that is too big. And with the lower boundary, that means that anything that is below that is just too small. It does not fit with the rest of our data. So we're going to go ahead and find out if we have any data points that are outliers from our data set. And to do that, we need our IQR, the Q1, and Q3. And I remember that our IQR was 5, and I remember that Q3 was 70, which means that Q1 must have been 65. And we can check to make sure, and that is what it was, 65 and 70. So now we're going to take this information and we're going to plug it into our equations to see if we have any outliers. Now, I don't know if you noticed, but we have Q1 minus something and Q3 plus something. And both of those things that we are adding or subtracting is 1.5 times IQR. So that's what I'm going to start with. So I have 1.5 times the IQR, is equal to 1.5 times 5 in this situation. So 1.5 times 5, 5 times 5 is 25, carry the 2, 5 times 1 is 5, plus 2 is 7, and so that means that we have 7.5 as our value that we are subtracting from Q1 and adding to Q3. Okay, so now we're going to calculate both our lower boundary and our upper boundary. So I have the lower boundary is equal to Q1 minus 1.5 times IQR. We have data value, or we have points for both of those things. Q1 is at 65, and our 1.5 times IQR was 7.5. So I have 65 minus 7.5, and that is equal to 57.5. Next, we have our upper boundary, and we found our equation for the upper boundary is Q3 plus 1.5 times IQR. We again have both of those things. So I have Q3 of 70 plus our 1.5 times IQR, which was 7.5. So I have 70 plus 7.5. And that gives me 77.5 as my upper boundary. So these are just guidelines. That's our boundary. That's telling us that anything above 77.5 is too far away, and anything below 57.5 is too far away. So if we go look at our data, we're looking for anything that is above 77.5 or below 57.5. And our minimum is 62 and our maximum is 73. So there is nothing in our data set that is below our lower boundary or above our upper boundary. So that means that we do not have any outliers. So our answer to this question is there are no outliers, or our data set contains no outliers. And that is our answer for our data set. There are no outliers. One thing to keep in mind, just to kind of try to help you remember, with the lower boundary, you're looking for things that are less than, and that's why we're subtracting, because you're looking for something that's a little lower. And for our upper boundary, you're looking for something that's a little more, and because it's more, that's why you're adding. So hopefully that can help you remember that as you are calculating. Otherwise, you're just going to have to memorize that. All right, so that is all of the types of numerical measure that we are going to be working with in our statistics unit. We will continue working with each of these types of numerical measure within the rest of our sections as we work at what does this data mean and what does it represent and how can we use this information? How is it helpful?